Hello, everyone. My name is Catherine Garcia, and thank you for joining us for the 3 pillars of unlocking greenhouse performance webinar. In 1959, AgSource was formed to serve Wisconsin dairy farmers. What began as a regional dairy records processing cooperative has now grown into the AgSource of today, serving industries that span the entire agricultural ecosystem. From cutting-edge soil, plant tissue, and water testing to agronomic consulting and full-service DHI testing, AgSource at its core is a source of truth. One test at a time, we help our clients make the best decisions, always grounded in data. I'm now excited to turn it over and introduce our speakers, Dr. Fred Hume and Garrett Johns. Garrett is actually who's going to be kicking us off today. So Garrett, I will turn it over to you.
Yeah, thank you, Kate. So today we'll be talking about the 3 pillars of unlocking greenhouse performance. And as Kate said, it'll be Dr. Fred Hume and then myself, Garrett Johns. Just starting off here, at the AgSource or on the AgSource team, we have Kevin Klink, who is the director of laboratory operations, who will show all of our labs here on the next slide. We have Chris Idson, who's the national sales director, Jim Friedrichs, or Dr. Jim Friedrichs, I should say, who kind of does all of our research and development as well as new testing methods and that kind of thing. And then myself is the agronomic support specialist for all of the labs. Just helping taking daily calls and stuff like that. So here we're showing all of our labs. We have 6 labs, 5 on the agriculture side, and then all of the greenhouse media testing will be done in Lincoln. So anything that's coming from basically anywhere on the media side will be sent to Lincoln to have the saturated media extracts done. And so with that, I'm going to turn it over to Fred here and have him take it away.
Okay, thanks, Garrett. Just as an introduction, I was formally trained as a plant scientist, but I've spent over 35 years in the greenhouse and nursery business, mostly developing and supporting products, specialty fertilizers, and growing media for the greenhouse and nursery market. My association with AgSource goes back over 20 years ago, where when at one point they were Harris Lab, part of AgSource was Harris Lab, and I have quite a familiarity with the type of testing they do for container production. I think my take home of this short discussion is, I think lab analysis, when used correctly, can be a very valuable tool to help manage ornamental crops. When we look at container production, it's a little bit different than field crop production. For one thing, growers are simultaneously dealing with a huge diversity of crops at the same time, hundreds of crops, different species, cultivars, ages, container sizes. So it's a real challenge to keep everything happy. Not as much is known about, since there's such a diversity of crops, there's not as much is known about the nutrition of these crops. So I think in general, the strategy is to get a good system going that keeps everything going okay. There's always going to be some special high demanding plants, et cetera, that you might have to prescriptively treat. The big issue with ornamental production in containers, especially, is things can change very rapidly, and these changes can affect the appearance and the value of ornamental crops. So you can't let things just be on cruise control. If you develop a good system based on data, and you can prevent a lot of problems. And worst case, if there are some problems arising, you can catch them early enough if you have data to work with. Another key difference in containers is growing media doesn't have the power, if you will, of mineral soil in terms of supplying and buffering the root zone. And I look at container production more like hydroponics. So you have to really pay attention to water and solutions going in there, fertilizer solutions. So irrigation water is a key driver along with fertilizer selection. And again, if you have the right analytical data, you can make informed decisions to grow a high quality, high value crop. Next, please, Karen. Okay, in my experience, a lot of things can go right in the greenhouse and nursery, and a lot of things can go wrong. But most of the problems that arise, and again, I've been dealing with growers for over 35 years, they fit in a few neat categories. They're using the wrong fertilizer. And when I say wrong fertilizer, it's not suited for the system, the water and the crop selection that they're using. More often than not, if you do some good due diligence with your water, you can settle on a good program, but a lot of times it's too much or too little fertilizer that can cause symptoms and affect quality of the crop. And a big issue is pH. pH in the root zone can be too low or too high, and those conditions can result in some pretty dramatic symptoms that'll affect the salability of your crop. Next slide. So what do you do about that? If you keep your eye on the ball, you can do some testing all along the way to monitor what's happening in the root zone, tied with your observations of the crop, scouting the crops, and every day and watching how they're doing, et cetera, based on your grower experience. In-house testing can be a valuable tool because it's quick if you have the right equipment, some EC, pH meters. There are even some iron-specific meters out there for sale. You get quick results. You can monitor pH, soluble salts, electrical conductivity of the soil. There's test kits that can do a quick assessment of alkalinity in your water or bicarbonates. You can use EC meters to check your water, the baseline of your water, the conductivity of your fertilizer solutions. That will give you some assessment of concentration. You might check, sort of do a ballpark check on your injectors. Are they injecting correctly at the right proportions? Is there something wrong? You can also check your concentrated stock solutions to make sure they're made up the correct way. And there's tables on fertilizer company, water-soluble fertilizer companies that give you some general sense of EC tied to concentrations. You can also do some quick tests on containers. You can take a sample out and do 2-to-1s or pour-throughs and look at the EC and pH of those. That'll give you some insight into what's happening. You can use these meters to do nutrient runoff, test the EC of the runoff to see what's happening there. And these tests can be useful if you keep if they're done right and they're done regularly the same way, and you can prevent potential problems before they are visible on the crop. But the big but there is they only give you a general sense of what's happening, and that's assuming the tests are done right. Next slide, Garrett. In my experience, you need to validate any do-it-yourself testing with a credible outside lab like AgSource. In my experience, I see a lot of poor equipment maintenance, incorrect sampling or incorrect sample preparation, lack of calibration, standard solutions of the equipment, batteries aren't replaced. That can really impact your data. You might get data, but the data could be very misleading. And if you don't have anything to compare it with, you're out of luck. You have data, but you have no idea what it means. The other thing I would say with on-site testing is you really can't apply published guidelines, pH, EC, to these test methods because a lot of guidelines are tied to specific methods. So you have to be really careful with do-it-yourself. It's a good thing to have, quick and easy, but you really need to pair it with a credible outside lab. Next slide, Garrett. So when you're looking for a dependable, independent lab, you want quick, accurate data, rapid turnaround time, state-of-the-art equipment managed by professional chemists that use consistent methods, have programs where they test standards to know that they have accuracy in their results. And I think AgSource offers all of those things and more. I think Garrett will talk to those in a little bit. My other advice is, if you use an outside lab, stick with one. I've had growers in the past, they'll use different labs, and they'll start comparing the results. Why isn't this result the same as this? And a lot of times it may be tied to methodology that the labs are using. You really need to use a lab and stick with it, and a lab that's using the correct methods. And in this case, for container media, we're talking about SME, saturated media extracts. Again, that Garrett will get into the details a little bit. Next slide, Garrett. So I think a professional lab can be very useful. If you look at growing a plant in a greenhouse or a nursery, I think it's almost like the disease triangle. You're looking at a balance of water, media, fertilizer, and the plant growing in there. And if you have insight into water, media, plant, and fertilizer, you can really improve and maximize your program. So you can understand the benefits of your water and your media. You can also understand water, maybe some challenges that you can manage or try to overcome. You certainly can use a water test to help design the best fertilizer program, especially if you're using water-soluble fertilizer. You can use the lab as a QA test. Even when things are running well, you do testing just to see what type of root zone levels, nutrient levels you're running, pH and EC that you're running, and keep those for later use. That if something goes out of whack and you start to get some symptoms, you can see if there's some deviation from that. You can use this data to support making adjustments to your production system, that you're not shooting in the dark, you're actually trying to work on some issue. And certainly, I think this is where a lot of growers might use a lab, is they troubleshoot when there's problems arise. But I think if you use a lab up front to help design the right fertilizer program and measuring things along the way periodically, you can avoid the last point where you're troubleshooting because you have a big problem and you're trying to figure it out. Next slide, Garrett. Now, I think in containers, like in field production, mineral soil is the big driver. In containers, irrigation water is the big driver. And you really have to know the nature of the water, the chemical nature of the water, to develop an optimal water-soluble program. And there's a few, I think Garrett will show some examples of a lab test, but there's a few important parameters that you can focus on that make a huge world of difference in the results you get. The first one is alkalinity. That's a measure of carbonates and bicarbonates. That basically is the buffering in your system. If you can think about it as dissolved lime in your water, and that can be useful to counteract fertilizer, acidic fertilizer, or other acidic influences to maintain your root zone pH in the right zone. From a nutrient standpoint, the big one is calcium. If your water has calcium, you don't have to provide calcium feeds. If your water doesn't provide calcium and you don't provide enough calcium in the fertilizer program, you're going to have problems, especially in sensitive crops that require more calcium. With calcium, it would be magnesium would be a good one. Typically, most waters are low in magnesium, not enough to support a crop, but it'd be nice to know whether you need to supplement with magnesium, because it's kind of one of those hidden fertilizer nutrients that magnesium, if it's insufficient in the system, can affect yield, size, foliar color, plant development, and it's an important thing. You may, depending on where your water is from, you may have some imbalances. You may have high boron. There's pockets in the country where there's high boron in the water, so you don't want to feed boron, extra boron in your fertilizer. You may have an excess of iron that may interfere with other microbes like zinc and manganese and cause imbalances. So you need to know that up front. A simple water test will tell you that. Additionally, there may be other ions in your water that can cause problems to plants. Toxins, if you will, chemical toxins. Sodium, it should say chloride, not calcium. That's a typo. Sodium, chloride, aluminum are things that occur in the, in the bedrock, in the groundwater, dissolved from minerals, and certainly they can build up to toxic levels to plants. A common issue I've seen in the last 10 years or so is infiltration of seawater into coastal area, into aquifers, and you see elevated sodium and chloride. You'll also see that in some pockets where they use road salt, and you're getting runoff into ponds, etc. So the key message is you really need to test your water. How often? At least once. I remember I had a grower call me up and he had really high EC, high sodium, high alkalinity, really terrible water to work with. And I said, well, what's the deal? What's this water from? And the guy had just built $2 million greenhouse range in an area. If he had spent 30, 40 bucks ahead of time, you probably wouldn't have grown in that area if you had a choice. It really is an important thing to test your water. I think another place where testing water is very important, and the hydroponic industry has grown leaps and bounds in the last few years, knowing what's in your water. A lot of times, hydroponic growers will use RO water. They'll kind of strip the water of everything, which I think is a mistake. You should test your ambient water first, and it may be fine to use for hydroponic purposes and have some buffering in it with some alkalinity, or you can do some blends. But you don't know that unless you test. Next slide, Garrett, please. The other solution test that can be quite useful is a fertilizer solution. So not only can AgSource test water, ambient water, irrigation water, but solutions, dilute fertilizer solutions. And this can be very useful to assess, say you have high EC in your root zone, you have plants wilting, you have salt burn on sensitive crops. And a lot of times it can be tied to your fertilizer delivery system. So most greenhouses especially would have a stock tank and an injector. And if you can sample a solution, a representative solution of your stock solution from your tank or your dilute solution once it comes through the injector, if you will, at the hose end, you can diagnose how well your injector system and your recipe is working. So you can figure out what your predicted values are, concentrations, and then you can see the actual to give you a process check, if you will, of the solution. This, I think, again, is key in hydroponic systems. There's some fairly highly sophisticated hydroponic systems, multiple injectors, and a lot of them are based on making a stock solution and setting the equipment at certain setting levels to get your intended target nutrient concentrations. However, a lot of hydroponic growers never do the process check and test what is the final concentration. I know I have the settings right on there, but they can be off, and it can wreak havoc in a hydroponic system, because in a hydroponic system, there's virtually no buffering. Basically, you are working in solution culture. And those solution tests can be an essential part of a hydroponic production system and should be used. Next slide, Garrett, please. The second pillar after water of the production system is growing media. Now, growing media, most growing media, and there's changes and there's new products coming on all the time, new raw materials. Typically, they're based in bark. composted aged bark. Wood fiber has grown in the last 10 years as a principal component, or stagnant peat moss from Canada, mostly from Canada. And these are the most prevalent mixes. And if you look at mixes, and there could be amendments, perlite, vermiculite, whatnot, at core, coconut core, pith, et cetera, to amend it to those. But they're primarily engineered for cost, bulk density. You don't want them too heavy because pots will be too heavy to ship. Availability of that raw material has to be available, and the physical structure. Mostly of the time when you make a blend or buy a commercial blend, the producer, high quality producer, is working towards a predictable physical structure, air and water porosity. But chemical nature as mineral soil would act as a driver, not so much. There's not a lot of cation exchange in there. And I, again, look at it as a hydroponic system. However, there are additives added to growing media to start them out at the right levels, if you will. And they might add lime, they might add gypsum, they might add starter nutrient charges to help them start out right. But those things don't mix, they don't persist. So you can use a test, even an unused media, and you can see, is the pH starting out right? Is the nutrient charge in there? If you are going to look at unused mix, I would recommend first you take the mix, put it in a pot, water it in, let it incubate for a couple of days in the greenhouse, and then test it. Then it's a true picture of what the plant would see, if you will, because it may take some water to solubilize the dry nutrient charges added to the mix. If in media, if the fertilizer program is suboptimal, you will see rapid changes in the root zone environment. And the only way you're going to know about that is to do a media test, or as Garrett will call it, an SME, a saturated media extract, which is one of the standard methods for looking at soilless media. You should be doing periodic media tests to monitor a crop. It's a very low expense to get a great picture of what's happening at the root zone. You can't see what's happening at the root zone. Obviously, scouting the crops, looking at color, size, et cetera, is very useful. But this is another tool to help you look at it. I think, coincidentally, I think Harris, way back when, worked with Warnicke, the guy who designed the SME test. If I'm correct, I think Harris actually worked with Warnicke on that methodology way back when. Next slide, Garrett. So a media test, or an SME, it's a snapshot of the root zone at the time of sampling. It won't tell you what happened last week. If you had put too much fertilizer on, had high salts, and it's leached in the meantime, it won't tell you that. So it will only tell you what's happening in the real time when that sample was sampled and sent in. You can use a media test again to assess commercial mixes. Say you're looking at shopping around for different mixes. I would suggest asking your manufacturer to give you data, but you can also on your own test it out to see if it meets your needs. More critically, some big greenhouses, a lot of nurseries are making their own growing media, and you can use a media test to assess the raw materials. Is there high aluminum? Is there high sodium in there? Garrett will talk later about carbon nitrogen. Is it green bark? Is it wood in there that's going to draw down nitrogen? You can do a CN ratio to assess raw materials. So those are all good things if you're looking at the components of your mix or assessing a new commercial mix or the one you're using now. You should, as I say, frequently test EC, pH, nutrient status during production, just to make every 3 weeks, say, during some major crops, to make sure everything's going well. There are many occasions in the greenhouse and nursery industry where growers have to inject acids in their water to counteract high alkalinity, bicarbonates in their water. And a media test will tell you if the pH, and the net result will be maintaining that optimum pH range that you're looking for. A media test will give you a heads up what's happening, how's the pH in the media trending. Again, you won't know that. Sometimes you won't see that symptom where I showed earlier of the iron toxicity until things get very extreme. And in that case, when you have those symptoms, it's very hard to reverse them. Are nutrient levels sufficient that you're feeding to support a crop? Are they too low or too high? Do you have to supplement? Do you have to add calcium? Is pretty common if you have low calcium, pure water. Micronutrients, especially iron. There's a lot of crops that are highly sensitive to pH, high pHs, or a high demand for iron. And media tests ahead of time will tell you, those levels are looking low. I better add some magnesium or some iron chelate to my fertilizer tank. If you have green bark, which is very common, I would say, especially in the nursery, nitrogen drawdown is a big issue because people are using poor quality raw materials, i.e. bark or wood. And media tests will show you, are you getting drawdown? What are your nitrogen levels tracking in the media test? You might be putting on 100, 200, 250 parts per million N. What levels are you maintaining in the root zone? Because think about it, in a container, basically what you apply is what you should see in a media. So your constant liquid feed, you should be seeing those type of levels. So near it, you will get some leaching, et cetera. Are you seeing buildup of sodium if you had sodic conditions? Those are all useful things you might find out by doing a media test. Next slide, Garrett. Now, the third type of testing is tissue. It would tell you the nutrient status of the leaves you sample. This can be very helpful if you're trying to diagnose some issue. You get some funny symptoms, you're not getting the right growth you need, tissue. But I would say if you're trying to, a lot of times people use tissue tests only when they're trying to troubleshoot. They have a big problem, they're trying to figure out what's going on. Tissue without media is not very useful, I would have to say. Ideally, you should pair a media test with a tissue. It'll give you a better insight into the nutritional status of the crop and the root zone. Key is sampling the right tissue type. For most ornamental plants, we would recommend the most recently matured leaves. You go from the apical down in the first set of leaves that are fully formed. That's what you would sample, because that's where there's charts and there's books and databases tied to ideal nutrient status of various ornamentals, but they're tied to that crop stage. And I know if you took young leaves and old leaves and turned them into the same lab, you're going to get different results, because you're going to get accumulation of things in older leaves. And if you're going to use the ranges provided with the lab tests, you're going to have the right sample type. Balance is very important, especially micronutrients. That's where you get a lot of issues that can rise up, and it can tell you if you have an imbalance happening. Manganese and iron will be a good one. Zinc and iron be a good one as well. The key thing I would say is tissue values may reflect a nutrient problem. The cause of that problem could be different. It could be environmental. A good example would be tomatoes, calcium deficiencies, but we know calcium under droughty conditions or high humidity conditions, calcium won't get taken up. So you have plenty of calcium, say, in the container, but it's not getting taken up. So it may not be a hole in your fertilizer program. It may be something else. Next slide, please, Garrett. So most growers use lab, I think, at this point where they have a big problem. They're troubleshooting. They're trying to figure out what happened. They're trying to figure out what can I do to reverse these symptoms. And you can shoot in the dark, guess. And sometimes, in my experience, advising growers, you might say, just give me a visual description of what's happening. Here's something you might try. It might hurt. I would give a recommendation. It wouldn't hurt, but might help. But you're shooting in the dark just based on symptomology. So again, you're troubleshooting. You want to do comparative sampling. You want to do not just an affected plant or plants. So plants, you might take samples from 3, 4, 5 plants and bunch them together, but you want a good unaffected plant versus an affected plant so that you can look for some difference between the two. Is there a possible nutrient deficiency or interaction that's happening? And unless you have something to compare it with, you have no idea, because with so many ornamental crops, some would accumulate more than others. So you really don't know if that's a normal or out of the normal scenario unless you do good versus bad. Again, what I said earlier, media and tissue, both affected and normal plants, can yield much more information to go off of than just one tissue sample from an affected plant. Symptomology can be very important, provide initial clues. You look at the pattern, location, timing, progression, type of symptoms that can be helpful. But unless you do the data, generate the data, you're really guessing. A lot of nutrient deficiencies may not be extreme or very noticeable. You may just have delayed production, off color, low production time, slight stunting. And if everything in the greenhouse or nursery looks the same, you say, hey, that looks okay, but you probably could get better potential out of those plants if you did some testing to identify if you're running suboptimal levels of some nutrient. Next slide, please, Garrett. And finally, I get down to once you have the data, you sample, right? You got the right tests, you're looking at the data. I would say medium tissue samples can narrow down possible causes. In this case, there's a rose on the right-hand side. You got chlorosis on the new tissue. And I would guess, just looking at that would be classic iron deficiency. So you can guess or you could test and validate that. But you collect data, look for patterns, timing, distributions. You have data, and then you're trying to problem solve here. My experience is many problems aren't that simple. They're complex. There's more than one factor causing those symptoms. In this case of the rose on the right-hand side, the problem is iron deficiency, but the cause is a high pH. So the grower may or may not be adding enough iron in their fertilizer program, but if the pH is too high, you're still going to get symptoms like that. The solution, you could overcome that perhaps with a foliar spray or two as a prescriptive treatment, but the true solution is to acidify the root zone to bring the pH down a bit to avoid those symptoms. There could be other things going on, and the temptation when you have some data in front of you is to look for the problem on the data. And I would say it gives you possible suspects of what's causing the problem, but not all problems are due to nutrition or solely due to the nutrition. You could have plant health issues, poor root, diseased roots that prevent uptake. You could have environmental issues like drought that could impact that. So you have to be very holistic and systematic, open-minded about that when you're doing interpretation of data, trying to figure out what should I do about this problem. And my advice would be to consult with an expert at your lab who's used to looking at that data, that can tell you, yeah, this, talk over the whole situation with you and say, yeah, this could be the problem. Here's a good program that I would try. You could do it on a small block first to see if you're worried about doing something wholesale. But you're working from strength of knowledge from the lab tests and not just guessing. That's it, Garrett. Turn it over to you.
Yeah, thanks for that, Fred. I think what we're talking about there goes well into this slide. So if you can't measure it, you can't manage it. And so in that last example, if you wouldn't have measured the media or the soil that the rose was growing in, you wouldn't have known that it was a pH issue. You would have thought that it was an iron issue, which it ultimately was, but adding more iron isn't necessarily the answer in most cases. So we're talking about the three pillars of greenhouse testing. We got soilless media, water, and then plant tissue testing. So I'm going to cover all three of these here and try to get through this. So why do we test our soil, media, water, and tissue? At the end of the day, it comes down to this right picture. We don't necessarily want to light our money on fire and just throw money at the problem. We want to know why we're throwing money at the problem. We want to know what fertilizer we want to use. Not, 2020 might not necessarily be the best fertilizer solution for every different problem or different crop that you have. So the testing allows us to know what we have in our media or soil, and then how we can pick the right fertilizer solutions. And then this middle picture is just showing that, if water and light aren't your limiting problems, or sulfur, potassium, and you're losing yield from something else, well, we need to try to fix that stave before we try to fix any of the other stuff. So what can sampling tell us? It helps us understand variability, and this really deserves a lot of planning. And as Fred's outlined, there can be a multitude of things that go into this planning process, but starting with a good sample gives us a baseline of what we can improve on, and then ultimately how we can have success. It helps us determine what practices are hindering our production. So that's mostly in the case of EC, and knowing what we might have a buildup of, or what fertilizers we're adding that don't necessarily help us, or we're getting a buildup. And then it's a tool for long-term measurement of success. So ultimately, are we making money by our fertilizer program, and then what we're sending out the door and ultimately selling. So I wanted to get into some of the stuff that Fred was talking about early in his presentation about accuracy and precision. So each state regulates labs for quality. And in our case, we are a part of 3 different quality organizations. So we have NAPT, we have ALP, and we also have ALTA, which is the Ag Lab Testing Association. So what happens is they send us samples, and then we run those usually blind, and then we report results back to them, and then they basically give us a score. Were we inside the range of acceptable outcomes, or were we outside? And if we're outside, then we have to look and see why we were outside. If we're inside, then everything's great. And so we strive to make sure that we're in those guidelines and make or have a quality result go out the door each and every day. So one of the bigger problems that I run into outside of the variability in each sample is trying to identify what factors influence the test results. So stuff like just variability between bales of media that you're getting. What sampling strategy did you use? Time of year. Did we take the sample? If you took a sample early in the year and you don't have say a starter charge in it, but then you take a sample later in the year and your pH dropped. Well, was that because of the nutrients that you're adding? All that fertilizer is acidifying the sample, things like that. But just trying to pinpoint why there was that variability. And then another big one that Fred hit on was when you're using different laboratories, or if you've used different laboratories in the past, you need to ensure that that both labs are using the same testing methods. So as Fred mentioned, you can have a 2-to-1, you can have a pour over. We run the saturated media extract. But just knowing that if you're comparing two different methods, that they're probably not going to be the same results coming out. And then ultimately, was it new media? Did you add compost before sending it in? Was there fertilizer that came in and the fertilizer charge? Things of that nature that can ultimately affect that variability. Now, this is a slide that I want to spend some time on and talk about. Why is a saturated media extract our go-to method? And it's because nutrients are taken up as water soluble ion. So as you can see in this graph, it's kind of trying to emulate, this is like a water channel that's going to the root. And so what that means is that nutrients have to be in solution for them to be taken up. And the majority of these nutrients, with the exception of phosphorus, are going to move by what's called mass flow. And so when the soil particles, so once they've supplied that root with nutrients, that root hair is going to basically give off a signal that they're going to try to release more of whatever nutrient that it's taking up. The other ways that nutrients can be taken up are by diffusion, which is the process of moving from areas of lower concentration to greater concentration, or excuse me, areas of greater concentration to lower concentration. And then ultimately, the last way is by root interception, where the root is just growing through the soil and it comes in and those root hairs come into contact with the nutrient. And so what the saturated media extract is telling us is what nutrients in the soil moisture absorb and transport to the roots via mass flow. And so this is why we use the saturated media extract, because it's essentially what's dissolving in your water or in the soil moisture and being transported to the roots. So I just wanted to give you guys an idea of what our process kind of looked like. So this bottom left-hand picture is just this, after we receive the soil, it's going into a cup, and then that cup is going to be basically saturated to, the holding capacity of the material. Once that happens, it's going to sit there, and we're going to let it, I guess, incubate. And then once that has been kind of taken up by the soil, it's absorbed all that moisture, we're going to pour it into this top right picture, which are our funnels, and then there's a vacuum pump behind that that's going to suck that moisture out of that sample. And then ultimately there's test tubes on the bottom of this, and that's the liquid that we are going to be running through the machines. So we got into pH a little bit. One of the best analogies I've heard for pH and how do you understand pH, like why is it important, is that pH is the bus driver and it decides who gets on and who gets off and where. So in the case of things like heavy metals, that pH being low is going to make those heavy metals a lot more available. Whereas if we can keep that pH in your ideal range, then we're getting a lot more availability of the good of our nutrients that we're wanting. And again, this can all be a little bit subjective in the group discussion like this, as the plants that you guys are growing are very wide. And I know that there's different pHs that different crops are wanting to be at. So just real quick, I've already hit on this a little bit, but Liebig's law of the minimum. So if you're low in potassium, and that's your yield limiting or your quality limiting factor, then adding zinc isn't how we fix that. Obviously, it would be adding potassium. So just making sure that by testing we're making sure that we know which nutrient is or soil characteristic is our limiting factor, and we're addressing that in the correct way. So here, I just wanted to compare a traditional soil test versus a saturated media extract. And this can also add to variability when we get samples in. People are expecting, say, a saturated media extract. Well, if you send it in on the wrong form, it's just going to get a traditional soil test. And that can just add to the confusion and the variability of the samples, because the traditional soil test is going to use a weak acid to pull off and break the bonds in the soil molecules. Whereas the saturated media extract is just going to use that water, like we've already discussed. So your bigger differences here are phosphorus. The biggest thing is because phosphorus there's not a lot of plant available phosphorus in the soil. A lot of that is either on the soil molecule or it's being held with calcium. And so we're using the traditional soil test to break those bonds. So you can see that the value on the traditional soil test is a lot higher than it would be on the saturated media extract. The other thing you'll notice is calcium. Calcium is a lot higher on the traditional soil test as well. So just ensuring that when you send a sample in, that you're sending it in on the right sheet and we're getting the right tests ran for you. An additional look at how we look at some of these would be looking at the soil health aspect of the media that you're sending in. So we're looking at things like microbial biomasses, the respiration percentage, and as Fred alluded to earlier, the carbon availability or the carbon to nitrogen ratios. And then how fast are we mineralizing nutrients, which probably isn't as big of a deal in this scenario, but you'll still get a little bit of mineralization. So where do we use those? When we're looking at compost maturity, it gives us an idea of how decomposed the raw material has become. So if the compost is deemed unstable, it will use nitrogen to help it with the decomposition instead of feeding the plants. And Fred hit on that a little bit earlier. And so as that compost becomes more stable, it delivers these nutrients to the plants instead of using them in the decomposition process. So when we're establishing if your compost is stable, we base that off the C to N ratio. What we generally use is a ratio of 25 to 1. We would consider that a more stable compost as we go down in that value. The CO2 respiration also gives us an idea of microbial activity in your material, and this, as the value goes up, there's more material, there's more decomposition, and so it's probably a little bit less decomposed than something that has a lower microbial respiration. Another way that growers can assess compost maturity is to look at the values of nitrate and ammonium. In the early stages of decomposition, you have more ammonia, where this has already been formed, and there's very little nitrate. But as we see that compost break down, we can see that nitrate concentration start to increase. And so once we get above about 50 part per million, it indicates that you have a maturing compost. And we generally only use that if the level is above, the combined level is above 250 part per million.
Hey, Garrett, can I interject another thing?
Yes.
Another parameter we would look at for bark, which is a big issue in especially in nursery production. They're using green bark with a lot of wood. Typically, green bark will show a very low pH, 3.5 to 4, and that's an indicator as well.
Yes. No, that's very good insight, Fred. Thank you for that. Let's see here. Now going up or moving on to the NPK fertilizer analysis, which will come on every test. this is the idea behind this was to give you an idea if you're out there selling compost or you're selling media, say I'm selling it by the ton, what kind of nutrient load am I giving or am I selling when it goes out the door? So we give this in pounds per ton, and then you can back figure that if if you're not selling it by the ton. So here's what the CO2 respiration reading looks like. So these jars are incubation jars. We put the saturated sample into a cup in there. In the jar, we seal it. It incubates for 24 hours, and then we use a vacuum to read how much CO2 is coming off of that, and then give you a reading from there. So how do we take a sample? When we're looking at taking a sample, we want to take a representative sample. If we're taking it from a pot, we want to take it generally from the middle third of the pot. One thing to note here is that irrigation type can affect where we want to take that sample from. So if you have things like sub-irrigation, you're pushing those salts up. But generally, we're going to take it from that middle third if you're watering from above. And then when we're looking at taking samples from compost piles, we want different depths in that compost pile, as well as if you have multiple piles, we want multiple, or we would not require, but we would want 2 different samples for the different piles. And then if they're made up of different materials, that can also be helpful to get 2 different samples. And then in total, we need about 2 cups of samples. So now getting into water testing, I'm gonna go a little bit faster through this as we're cutting it kind of close on time here. But we get things like we talked about earlier, water alkalinity. You can see that in the hardness and the bicarbonate. We're giving you an electrical conductivity reading, total soluble salts, all things that are helpful when you're trying to put together a fertilizer program. And then at the bottom of the report, we're giving you the actual NPK micronutrient readings and parts per million, and then mill equivalents per liter. And then the last bullet point here is plant tissue testing. So as Fred, he hit this home really well, I thought. A tissue test alone, unless you're doing it weekly over the season, isn't all that valuable. And the other thing that he stressed that I liked was that if you have a problem spot versus a good spot, take 2 samples, and then we can compare those 2 samples to ultimately try to find a solution for you. And the other thing he said was 1 point in time is not all that important. It's more looking at the trend over time, so that we can make those better management decisions. So how do we take a tissue test? We have a lot of different crops available. I have the link here, and it will be in the email that you receive after this. But just going on there, making sure that you're taking the right tissue parts. Tomatoes have been a big one this year. We need to know what stage your tissue or your plants are at, and ultimately what kind of plants you have. In the case of tomatoes, are they determinate? Are they indeterminate? Those all have different ranges. So it's helpful to get all of that on your submittal form. So here would be our weekly tissue sampling form. So this is just allowing you to go throughout the season and see how did my nitrogen or how did my sulfur trend throughout the year? Am I keeping up with my fertilization? Am I fertilizing too much? Not enough. But it's just a very helpful tool in visualizing where that could be throughout the year. So managing nutrient applications, you're evaluating fertilizer treatments, sources, rates, timing, how long does it take that fertilizer to get into the plant? What source worked the best? What source got into the plant and elevated my levels the most? All things that are useful when you're trying to evaluate what fertilizers you want to use. I think we've already covered this slide. I'm just going to skip that one. So in summary, your results reflect the whole process from your sampling procedure to what you put on the submittal form to kind of what you're expecting out of it. One test or one type of test is usually not enough in most cases, as we've covered. We want to use the solutions provided to get a complete answer to the questions that you have. And so more testing is almost always better. And then a couple of things to just watch out for: high pH and high EC. And then how do we evaluate what's causing that? And then if you're using handheld meters, calibrate early and often. So with that, here is our contact us, and then as well as some resources for technical bulletins. So you'll find a media technical bulletin on there. And then if you have additional questions or want to get set up with testing, if you just go to the agsource.com/contact, it'll allow you to get in contact with us, and we can help you out from there.
Great. Thank you so much, Garrett and Fred. We did have a couple questions come in, so I'm going to go ahead and ask those. I'll try and direct them depending on when they came in. First question was, how often should these tests be conducted for optimal plant growth?
It depends. Depends on the crop, the value of the crop, I think. But a typical, if you had, let's say a poinsettia crop would be a good one, you would test you'd probably test, which is going to be about maybe about 15-week crop. You'd probably test every month, 3 weeks to a month, be sufficient. Obviously, the water you should test before you have a major crop, just to make sure it hadn't changed from the past, which can happen. I think every 3-4 weeks would be sufficient, Ken.
Perfect.
Gary, I don't know if you have a.
No, it's okay.
I think that was good. Did you have any more questions, Kate?
We have a couple, but go ahead and expand on this, Garrett.
Okay. I guess I just had one, while we were going through there. I'm seeing more and more media companies that are adding microbes and like mycorrhizal inoculants to their mixes, maybe in place of like a starter shot. What are your thoughts on that? And yeah.
You asked me, Ken.
Yeah.
Yeah, I'm skeptical of that. Whether they persist in that environment.
Mm-hmm.
I'm open-minded, but I'm skeptical of that. A lot of times I see whatever you introduce, you flood the system, and then they don't persist.
Mm-hmm.
There's a lot of ways to grow, and there's a lot of strategies. But yeah, I'm a bit skeptical, I have to say.
Yeah, that would be my question is, if you're saying that you're adding more nitrogen or the microbe is going to fix more nitrogen, it's pretty hard to test for that unless you know exactly when they're going to be, when you see that increase in nitrogen or whatever they're saying.
Yeah, and I would think probably a longer term crop would be more likely with repeated applications, but I know growing media companies will add them right in the beginning. I have no idea, how you would assess had they persist all along, as it even after. I have no idea.
Okay, we are at time, but we do have one more question. Garrett, this one's for you. How long does it typically take to receive results from AgSource?
So it depends. Usually 2 to 3 days. Now, if you get our complete package with the CO2 respiration and the C to N ratio and all of that, I usually say add on about a day, because we're incubating that respiration sample for 24 hours. So right off the bat, it just starts you off a day behind. So usually 2 to 3. If you have the respiration, then just add an additional day.
Perfect. Thank you so much. Thank you everyone for joining us today. Thank you, Garrett. Thank you, Fred, for all your insightful information on this topic. We really appreciate it, and we hope everyone has a wonderful day.